Good morning. Welcome to class 10 ICSE Maths. Today we are going to do the quadratic equation part 2 and we are going to understand how we are going to solve when a quadratic equation is given in this form. Now we already know that a quadratic equation has to have maximum power 2 for the variable. So what we will do is we will convert this x squared into another variable and we will assume saying let x squared equal to m. So therefore our quadratic equation becomes x squared to the power 2. So it's a square of x squared. So if x squared is m, then x to the power 4 becomes m squared. Minus 5, x squared will be substituted as m and minus 6, and that's equal to 0. So you see what looked apparently as something totally different than a quadratic equation, we converted into a quadratic equation. Now we have one variable and the maximum power is 2. Once we have done this, we can solve this as a normal quadratic equation. The product will be the coefficient of m squared multiplied by this, that is minus 6. And because the product is minus, you will get a difference, which is the coefficient of m, which is minus 5. So you are going to take the difference as minus 5, which means one of the factors is bigger than 5. So you will get the factors as 6 into 1, that is 6, 1, 6. And because the product is minus, you will have the factors having different signs, that is minus 6 and plus 1. Now we start solving this. Therefore we have m squared minus 6m plus m minus 6 equal to 0. Now you group these together, so you will take m common and you will have m minus 6, and between these two 1 is common and you will get m minus 6 inside the bracket, and that is equal to 0. Then again you will see m minus 6 and m minus 6. These are common factors here between these two terms. So you will have therefore m minus 6 into m plus 1, and that is equal to 0. Therefore you will say m minus 6 equal to 0 or m plus 1 equal to 0, and that will give me m equal to 6 or m equal to minus 1. Here we have used the zero product rule. If two brackets multiplied together give you 0, so either of the brackets will be equal to 0. So either m minus 6 is 0 or m plus 1 is equal to 0. Now that you got m equal to 6 and m equal to minus 1, we will resubstitute. So we will say resubstituting m equal to x squared. So you will have x squared equal to 6 or x squared equal to minus 1. Now x squared equal to minus 1 will give me x equal to plus or minus root of minus 1. This doesn't make sense because this is not a real number. So we just say not possible, since roots are not real. And so we continue with this. Now here you will say x squared minus 6 equal to 0. So you will have x plus root 6 or x minus root 6, and that product will be equal to 0, and that will give us x plus root 6 equal to 0 or x minus root 6 equal to 0. That should continue with x equal to minus root 6 or x equal to plus root 6, and therefore our solution set is minus root 6 or root 6. We cannot take these roots because these roots are not real, and that is our answer. Now in this place you could have even done after this step x squared equal to 6, therefore x is equal to plus or minus root 6, and then directly we could have written this, but I personally prefer showing the zero product rule and then getting the values of x as plus root 6 and minus root 6. So that is how we have done this. Now let us come to the second one in this category, where we apparently see no x to the power 2, highest power 2 we do not see. In fact, we will see over here that there is a fraction which is under root, and then again this fraction which is the reciprocal of this. So when we have something like this, you will again assume let root x minus 2 equal to m. So this is our assumption, that we will take m as one of these fractions. And so if x upon x minus 2 is giving you m, then root of x upon x minus 2, which will be m, so x minus 2 upon x becomes 1 upon m. So you will see this fraction and this fraction, they are reciprocals of each other. So now we will have this whole equation becoming m plus 1 upon m, and that's equal to 5 upon 2. Now you can take an LCM here, but I prefer this entire equation, I will just multiply by the denominator. If I multiply by the denominator, when I open this bracket, m into m will give me m squared, plus 1 upon m into m will give me m getting cancelled, so that will give me 1, equal to 5 upon 2 gets multiplied by m and it becomes 5m upon 2. Now we will have to cross multiply, so you will get 2m squared plus 2 is equal to 5m, and then we will arrange all the terms, bring them to one side, and we will have the other side becoming 0. So you'll have 2m squared minus 5m plus 2 equal to 0. I made sure that my 5m, when it came this side, it was in the descending order of the powers. Now you will see that here the product is plus 4 and the sum is minus 5. Now when the product is my product is plus 4, which means that when I take the two factors, their sum should be 5, so both the numbers should be less than 5. So factors of 4 which are less than 5 are 4 and 1. So you will get here minus 4 and minus 1, double check. If you multiply these two, do you get this? Yes. If you add these, do you get this as the sum? Yes. So we are now ready to write this as 2m squared minus 4m minus m plus 2 equal to 0. Then again we will do grouping. Here you will have 2m common and you will have m minus 2. Here minus 1 is common. So when we write this m, it becomes positive inside the bracket, and this plus sign becomes a minus because we have taken minus 1 common, and so we will now have in the next term two terms out here, out of which you will see m minus 2 is common, so m minus 2 into 2m minus 1 equal to 0. Therefore now we will use the zero product rule. Either this bracket is equal to 0 or this bracket is equal to 0. So that will give you m minus 2 equal to 0 or 2m minus 1 equal to 0. Therefore you will have m equal to 2 or 2m equal to 1. That will give us m equal to half. Now m was the substituted value. So we are going to resubstitute. So we will say resubstituting m equal to under root x upon x minus 2, and that will give us under root x upon x minus 2 and that is equal to 2 or m or under root x upon x minus 2 is equal to half. So you will see that m equal to 2, m has been substituted here, and here m is equal to half, m has been substituted out here. And now that will give us squaring both sides for each equation. We will have x upon x minus 2 is equal to 4, or x upon x minus 2 is equal to 1 upon 4, square of 1 1, square of 2 4. Now cross multiply. So you will have 4x minus 8 is equal to x, and here it becomes 4x is equal to x minus 2. So therefore you will have 3x is equal to 8, or 3x is equal to minus 2. Therefore x is equal to 8 upon 3, or x equal to minus 2 upon 3. Now that we have the values of x, our solution set, either we can say therefore solution set is equal to 8 upon 3 comma minus 2 upon 3. But if they ask you a question, give your answer to 2 decimal places. So if they say correct to 2 decimal places, then our x becomes equal to 8 upon 3 or minus 2 upon 3. That therefore becomes 3 2's 6 and 2 remains, so we have 0.667, or here it will be 0.667. Now if you want to round off to 2 decimal places, after decimal point you will count 2 decimal places, and this is the place where we have to round off, and out here this is the place where you have to round off. And so therefore our solution set becomes equal to minus 0.67 comma 2.67. We have to round off to 2 decimal places. 2 decimal places means the second decimal place and on the third decimal place. If this digit is 5 or more than 5, then this gets rounded off to the next digit. So 6 becomes 7. On the other hand, if the third digit over here, third decimal place, was less than 5, then this 6 would have continued to be 6 itself. Here again the same thing, 2 decimal places. Next digit is 7, and so this will be rounded off to the next digit. It will become 6, will become 7. Let us take another case where sometimes in ICSE they will ask you, if give your answer correct to 2 significant figures. Now in case of significant figures, remember what is your x? X is 2.667, or it is minus 0.667. Now in case of significant figures, it is different from decimal places. In case of significant figures, remember all non-zero digits are significant. So this will be significant, this will be significant, this will be significant, as well as this will be significant. So 2 SFs means you will round off here. And in case of this decimal, this is a pure decimal. Why it's a pure decimal? Because there is no whole number here. And therefore, because there is no digit before the decimal point, this 0 is present only to signify that there is no digit out here before the decimal place. So this 0 becomes non-significant. This 6 is significant, This 6 also significant, this also significant. So now if you are asked to SF, you will count up to 6 and therefore you will have the solution set equal to 0.67. So we have two significant figures and this is having negative sign, and here you will have to take 2.7. Why did it become 2.7? Because you are asked two significant figures. Two significant figures means this is significant, this also is a significant figure because this is a non-zero digit, this is also a non-zero digit, and all non-zero digits are significant. So you round off to one decimal place, which is giving me two significant figures, and then you round off looking at the next digit. This is more than 5 and this therefore becomes 7 as the next digit. So this is our answer. So that is how we are solving some of these questions in which apparently the highest power is not 2 for the variable in the quadratic equations. Now this is where we are going to stop for this particular session, and in quadratic equations part 3 I will talk to you about some other formats whereby you will understand how to solve quadratic equations. Thank you for watching.